Did you know that the way a VFD converts AC to DC directly impacts motor performance, efficiency, and even your electricity bill? In fact, choosing the wrong type of rectifier in a VFD can lead to power losses, overheating, and poor torque control. But what exactly is the difference between a controlled rectifier and an uncontrolled rectifier in a VFD? And which one should you use? Let's break it down. Before we compare them, let's quickly understand what a rectifier does in a VFD. A variable frequency drive, VFD, converts AC power into DC in its rectifier stage and feeds it into an inverter to convert it back into variable frequency AC to control motor speed. The rectifier plays a crucial role in determining how well the VFD manages power and controls the motor. Based on its design, rectifiers can be classified into two types of VFD uses: uncontrolled rectifiers, diode-based, and controlled rectifiers, Thyristor-based or IGBT-based. Let's break down the key differences. First, on the voltage control front, uncontrolled rectifier VFDs use diodes to convert AC to DC. Diodes are passive components that allow current to flow in only one direction but have no control over the flow of current, meaning the DC output is a fixed and unregulated replica of the input voltage. So it provides a fixed DC bus voltage based on the input AC voltage. So if the input voltage fluctuates, so does the DC voltage. This can impact motor performance. Fixed DC voltage means limited speed and torque control. A typical 10 HP fan motor running at full speed doesn't require variable DC voltage. It can be used on simple conveyor systems where precise voltage regulation isn't critical. So, an uncontrolled rectifier VFD is a great low-cost option. While in controlled VFDs, it provides adjustable DC voltage, which is required to control output DC voltage precisely through firing angle adjustments. This is used for excellent voltage regulation for motor speed and torque control, even with fluctuating input. It also helps avoid DC undervoltage and overvoltage faults. This is used for high-precision machine tools, wind turbines, or crane hoists, where consistent voltage is crucial for optimal performance. Imagine you're running a crane hoist motor that needs precise torque control at low speeds. If you use an uncontrolled rectifier VFD, it won't be able to adjust torque properly, causing jerky movements. But with a controlled rectifier VFD, the motor speed and torque can be adjusted smoothly, preventing sudden shocks and ensuring safety. Now let's talk about power factor and harmonics for each type. Uncontrolled VFDs have a relatively good power factor at full load, but the power factor decreases at light loads. It generates significant harmonic distortion, which can affect other equipment on the power grid, so it can be considered for large pump applications with consistent full load operation. Controlled VFD can improve power factor, especially at partial loads, by controlling the firing angle, but introduces more high harmonics and power distortion, can cause electrical noise, and reduce power quality compared to uncontrolled rectifiers, requiring careful filtering. It finds applications requiring regenerative braking or grid feedback, where power factor control is essential. The most important thing, regenerative braking. Let's see how both handle this thing. Uncontrolled VFD power cannot be fed back to the supply as it uses diodes for rectification, so it cannot perform regenerative braking, leading to energy losses. So the energy generated during deceleration is dissipated as heat across the DBR placed on the DC bus. It finds application on standard fan drives, where braking is achieved mechanically. Controlled VFD is capable of regenerative braking due to having SCR or IGBTs for rectification, thus allowing energy to be fed back to the power grid, improving efficiency and saving on electricity bills. It finds application on elevators, cranes, and electric vehicles where energy recovery is crucial. Cost and complexity. Uncontrolled VFDs are simple and reliable. Fewer components mean fewer chances of failure, so it has limited functionality. But it is cost-effective as diodes are cheaper than controlled rectifiers like thyristors. While controlled VFDs use complex electronic circuitry having SCRs or IGBTs instead of diodes, making it costlier than uncontrolled rectifiers. It requires proper tuning and programming for optimal performance. So, Which one should you use? It depends entirely on your application's specific needs. For simple, cost-effective applications where precise voltage control isn't critical, like fans, pumps, and conveyors, an uncontrolled rectifier is often sufficient. However, for applications like cranes, elevators, and precision machinery requiring precise control, regenerative braking, or improved power factor, a controlled rectifier is the better choice despite the higher cost and complexity. I hope this video helped you understand the key differences between controlled versus uncontrolled rectifiers in VFDs. If you enjoyed this explanation, hit that like button, subscribe, and let me know in the comments. Which type of VFD do you use in your industry? Thanks for watching, and I'll see you in the next video.